Now, there's the functions I haven't copied down correctly. Guys, the first part says on this, and your quiz is going to look something like this next week. Name the zeros and their multiplicities. I would name the zeros as 0, 3, and -2. Back to 0, the multiplicity is what? 3. The 3 is the multiplicity of 1, and -2 is the multiplicity of 2. Do we agree with those? That's all I'm asking, is name the zeros and multiple responses here. Yes?
Well, at first I thought it was -1, but that's the leading coefficient, right?
Yeah, that is.
You're right.
Okay. Now, the end behavior, guys, this end behavior depends upon if you should expand this out the very first term. And guys, I see the very first term, see if you agree with me, I'm looking at it quickly here. Is that a negative x to the 6? Is that what the first term would look like in the expansion, yes or no? Negative x to the 6. If it is, I need to answer these two questions for end behavior. And since you guys are moving on into math 7, let me use the notation. Let's try to find the limit as x gets large of my function in that direction. And then another question here is, find the limit as x is approaching negative infinity of this function. And that all depends upon this. Now, tell me, I know many of you probably are trying to visualize, Professor, what does a negative x to the 6th graph look like? Okay, it's somewhat like a parabola, but is it opening up or opening down? Opening down. So I would think then, as you approach positive infinity, and here's another way to think of it. I agree with you, that's shaped like a parabola. You guys are saying opening down, not 100%. But also it says x is approaching infinity. That means x is a large number. It's getting larger. So you could say, Professor, can I just go back and replace here without visualizing x to the 6th graph? Just replace x by some large number, that's what it says. You're going through large numbers, and choose a number, put it in there. When you raise it to the 6, common sense tells you it's going to get even larger, isn't it? You put 50 in there, and you raise 50 to the 6. Big number. And the prefix is negative though. So are you actually going to end up with a negative, some large number? And as I say, you tell you quickly, it's that. On the other end, this time you get to replace x, if you do not want to look at that graph, by a small number, approaching negative infinity, like a negative 50. Put a negative 50 in here. When you raise it to the 6, it turns into a positive big number. Prefix, negative, and all that together gives you another negative infinity. Do we agree? Okay, so now I know what's happening on the ends here. Zeros. I got 0, I think we mentioned this, out to 3, I'll jump out there, and then down to a -2 here. Point these out. These are my zeros, they call them x-intercepts. Y-intercept, obvious this time, it's 0. Now the end behavior, say, Professor, can I go ahead and do this on the end? Of course. Right, determine the end behavior. This on both ends. Now you look at where it crosses, where it touches, and sort of finish up. Oh, and I also give you a little table maybe to plot some points to make it look a little bit better. I think I did, didn't I? I think I did. Check and see if I did. Got that right in front of me here. Here it is. Now I give you a table to refine the graph. And you guys who may have found the values for me can help me out here. At a -1 and a 2. In other words, just go back, replace x by -1, replace x by 2, find some values. Did anyone find the values here? How about -1? What's -1? How much? -4. -4? You guys agree? And did anyone try 2? 128? Will just help me get the graph a little bit better here. And I guess, let's see what else here. Got the end behavior done. I'm about to finish this thing up then. let's sketch it. I think it's all that's left. So guys, based on what you guys have given me, let's see, I'm gonna go from left to right. I'm at -2. I think you guys told me -2, it should do what, touch? Is that true? Just touch? So it looks like at this point, we'll come down. Now, you guys told me -1 dropped down to what, -4? That may help you say, well, Professor, you're not gonna drop down very much based on that table there. -1 goes to a -4, then it's gotta come back up and pick that up. You guys agree? Something like that? That's why I did that little table there, it does not drop down too much. And then it goes through 0, and I think 0 was, yes, that's odd there, so it crosses. How high up does it go? This may help you, it goes way up. I know at 2 it goes up to 128, so that might tell me, well, Professor, you better make it go way up there, and then come back down and join, and make this look better. Yeah, something like that. You guys agree? And that's the graph. That's a rough sketch of that function. And I guarantee if I have Mr. Park to do the graphing device he has back there and graph this, it's pretty much what you'll see on his. That's what I said. Any concerns here? Did I ask anything else about this? My goodness, that was a quiz. Get a point. Some of my students shaking their heads about Professor Kidd. Let's do elementary. But that is it, that's what we're actually talking about. Now I'm gonna leave this. And the graphing. Now here comes, we'll start part 1 again. Guys, we'll label this as, to finish up what I need to do here, the zeros of a polynomial function. Find the zeros. Mr. Professor, it's easy. It's easily done. Well, first, let me give you a function, a polynomial function, and let's say it's p of x is equal to this. I'm thinking about one real quickly here. It looks like that. And I ask you, what are the zeros? The x-intercepts, in other words. There's no problem there. Guarantee you, probably all my students could just look and say, Professor, no issue. The zeros are, what's the first one you might mention as a zero? It's a zero itself, and has a multiplicity of 2. Like what we're doing, and we'll leave this something else though. Next one, x plus 1 may indicate there's a 0 at -1, -1, multiplicity of 4. And the last one there, 1/2, has a multiplicity of 5. You're finished. Yeah, you said, Professor, this course is getting so easy. I love this course. You'll get an A for sure. This course is way, way too easy. And all my friends about Ramsey, best too, take Ramsey. That's when you do 1 + 1 = 2. Yeah. Now, next, try to find the zeros. Next one looks like this. Hang on. Why not? P of x equals, we'll lead you into it, 4x cubed, subtract x squared, subtract 4x plus 1. That's a polynomial function. How many zeros should there be? What's my degree? What's my highest exponent? 3. You gotta find 3. Now, is this one as easily answered as this one was? No. So what might you try to do here to find the 3 zeros? Not as easily done as this one. Give me an idea. Anyone?
Take all 6.
And well, first tell me, I planned my lesson to do this. Tell me first, what's the major difference in this one that was so easily done, and this one?
factored out.
Thank you. Andrew says the top of professor gave it in factored form. Now I'm asking, can I factor this one?
Not in.
Many students may say, Professor, I'm factoring, you got to factor that? Yeah, I gotta do something if I can, and make it look more like that first one, but in factored form. I'm looking at it, and I gotta be careful myself here. It might factor. Does anyone have an idea? I know what you're accustomed to. You're accustomed to that middle school across the street. What factoring they're doing over there, which we've seen some in this class. Well, we're moving beyond that. Bill, go for it.
I don't think it says, but you have to use you.
I could rewrite everything in terms of you. I wouldn't have to. I don't think that's gonna help me too much.
We can split the, we can split it in two and take out x squared. and take
Whoa,
out-
whoa, whoa. So he says, look at this. He says, Professor, break those four terms up into pairs. Do it like this. First. Oh, he's being clever. Now he tells me in the red there, the first two, he says, take out a common factor of x squared. Leaving me, I guess, 4 is it? Subtract what? Was it x squared? X.
Yeah,
X. X. 4x.
One.
Subtract 1 in the red. Is that true?
Mhm.
And then I think the next one was, I think there was a minus there. Could I pull out on the one in blue, these two, could I pull out maybe a negative?
Yeah.
If I pull out a negative here in the blue, what's in blue? I get all these markers straight here. Pull out a negative here, that would leave me this, and see if you guys agree.
Yes.
Did I factor it with his help? Did I do the pairing? Grouping? They call it grouping. They asked me to group my pairs. Now, he's not quite finished. What are you gonna do next?
Take out 4 x minus.
He said, wait, Professor, now these match up. How cute. He's gonna take out 4x minus 1 like a common factor. He's gonna take out 4x minus 1 out of the red, out of the blue. If he takes out the red, you have this left. What am I gonna have left if you pull it out of the blue? 1. I'm blessed. Not quite finished. 2 more. This is the easy part now. Don't miss this easy part. You write down the hard part for me. Not quite finished.
Then x squared.
No, come on.
X minus 1.
Yeah,
squared.
there you go. X squared minus 1 is the difference of squares, they call it. Could that be factored further into, from across the street, this? Are you kidding? Now, next week on the quiz, I always ask this, on the quiz, would you prefer me, when I construct the quiz next week, would you prefer me giving it to you in this form? Rather than this one? Would you prefer it written already in factored form? And just list the zeros? Wouldn't you like that? Is that gonna happen? That's not gonna happen. That's not gonna happen. It's gonna be looking more like this, and this one could be factored, we have it now factored. Now, one of the zeros, easily done. Just go through and set each one of these that he helped me with here. Each one of these equals 0. This one, this one, this one. And it looks like I'm gonna solve and get an x equals 1/4, that's one of my zeros. X equals 1, another 0. X equals -1, another 0. I have 3 zeros. I was expecting 3. Replace them. 1/4, 1, -1. Those are my 3 zeros. And my degree says find 3. I found 3. And that is nice. Now, throw another one at you. Hang on. I love this lesson. Coming up. Here it is. Letter C. Find the zeros of this function. Let's call it p of x, polynomial. And this one looks like it has 4 terms. It's cut down correctly, so it is. It's a cubic, 4 terms, it's a polynomial, leading coefficients of 2, constants -6. I gotta find 3 zeros. There's 3 zeros there, I gotta find those, and I had wonderful help with this one. He told me exactly what I wanted to hear. He said, factor that, professor, factor it. I will tell the entire class ahead of time. This one we're not factoring. You can move all day. Reach your limit. You may not be able to function. You can do it all day. It's not gonna factor. But I've still gotta find 3 zeros. Now, let me describe something to you before I jump into, some students after I get into it may say, Professor, I sort of remember doing this somewhere. Not quite ready yet. Oh, by the way, before I show you a little routine here, does anyone have a guess as to, I'm looking for 3 zeros. And notice I said just find the zeros. They could be complex. In other words, some may have an I in them. Or they could all be real. We don't know yet. Does anyone have a guess as to what maybe at least one of the 3 might be? Now, here's what I got to share with you and lead you into what we've got to do. There are 3 zeros. I can find them. Before I do this, I'm going to go down here. Let me show you something beautiful. I'm going to give you this. For a function. Nice little quadratic, still a polynomial. Cute little quadratic. And I actually found the zeros. You say, Professor, no. You're going back to that? For some reason, I'm sure, Professor. Or you're just a little tired today, maybe. If you're going back to this, you know Professor's going to factor. That's what, guys? Split this up. You know the zeros are, I made no mistake in any signs there, are those the zeros? And you place this right here. And you leave class after a quiz with a big smile on your face, saying, I know I got that one correct. I know I did. Now here's the story behind this. We all can do that. There's a story behind it. That's going to lead me back to what to do here. Wait, you see what we've got to do here. Here goes the story. When I was in grad school, they had me working as a supervisor of student teachers. Some of you guys may have had a student teacher in your classroom. Those who plan to teach had to go out to the local high schools, and they had to practice with a master teacher, a teacher there on campus, and they had to do a little 6-week or 8-week practice. So my job as a professor was to visit that school and sit in the back and observe the student teacher and critique and talk to the student teacher and then suggest and say, oh, that was good. No, I think you should try this and so forth. This one's horrible and kids are out of control. No, don't do that. Those things. So I walked in and one of my student teaching, she was teaching something like this. And she hadn't started. I was sitting in the back. And she says, she talked to me. She says, Professor, could you sort of help the little guy who's sitting next to you back there? I said, sure. She said, what's the problem with him? This one, is he out of control? What's wrong with him? He doesn't know how to factor. And there she was teaching factoring. And she had not shown quadratic formula. I guess it was like 7th grade or something like that. They had never seen quadratic formula. She was showing them how to factor, and this kid did not know how to factor, and all of a sudden she's asking to solve this. And she led the other kids into factoring. They said, oh, and they agreed, these were the factors, and so forth and so on. He was just sitting there looking. And she finally asked what was the answers. They didn't call them zeros there, math 7. What are the answers? And most of the students said +3 and -2. And they got from here. That's math 7. I'm very proud of the class, she was doing a good job. But this one kid just could not factor. He just could not do it. And now all of a sudden I looked on his paper, he had the answers. I thought, whoa, I thought she said he couldn't factor. And definitely he can't use quadratic formula, he had never seen it. But he had the answers. Guess what he did? Because I finally moved over and started talking to him. I said, how'd you get those answers? She was looking for this. He didn't have this. He had that. So where'd you get those numbers? Guess what he did? He said, he said, I went down to the constant. And then on the side there, I listed all the factors of -6. What times what will give me a -6. And he listed them like this is one pair, this is another pair, this is a pair, this is a pair. Those are all factors of numbers you multiply together to give you a -6. This guy was clever. That was what was happening. He was just clever. I said, well, how did you decide it was these two that worked? So he said, he just listed all the factors of the constant term. I guess how you decide which of the ones did work. Guess what he did? He went back, he's patient, he went back and plugged in these, thought it wouldn't work. Plugged in these, back here, for the x, wouldn't work. Finally got down here, plugged in these numbers for the x, it worked. I said, really? Took a little time. So I bragged on him. I said, my goodness. No one else was thinking like that in class, just you. I said, wow, she wanted you to factor. You didn't know how to factor. So, me being me, I said, let's try another one. Okay. So I brought this in. I said, let's try this one. 6x squared plus 5x. It's like I subtract 4 is equal to 0. I'll move that up real quick. Let's hope it works out for me. Think. Okay. Whoa. Now, those of us who know how to factor, help me. Let's see if this does factor. He didn't know how to factor. But if it does factor, guys, let's see if it does. You guys who are good at factoring, help me out here. Is it a 2x and a 3x? Or that 6x squared? Is it true? And what else would I need to make this factor? This is a middle school problem. Maybe a +4 here and a -1 here. Check it. You guys who are good at factoring, is that it? Are those the factors? Now, he had no clue. And she asked, or I asked, she wasn't doing one like this. I asked him, I said, now, find the zeros for this, or find the answers for this. He said, oh, I'll just do the same thing I did here. I take this, good for you, and you're going to list all the factors of a -4, like 1 times -4, -1 times +4, 2 times a -2. I think those are the only factors of -4, right? Now, and he was patient. He said, yeah, I just want to use that little method. Just list the factors of that constant term, and then be patient and test them. Okay, guys, so if I test 1 here, I'll do it quickly. Replace x by 1, I get 11 subtract 4. Well, that's not going to satisfy that. If I try -4, that's 16 times 6. I'm getting big numbers here. What is that, 96? Geez, I think it's 96. 96, I think it is right. Subtract 20. And you see ahead of time, it's not going to give you 0, is it? With those big numbers? So that pairs out. He was very patient, so he jumped down and tried this one. You put a -1 in there, that makes that 6 minus 5. That's 1. 1 subtract 4 is not going to give you a 0. You put a 4 in there, it got worse. Not going to give him a 0 when he plugs in. He said, well, maybe it's got to be these. Put a 2 in there. 6 times 4, 24 plus 10, oh, it's getting worse. It's not going to give me a 0. -2 No. So he plugged in all those 6 numbers, I think it was, and nothing worked. He was happy at first, but a smile came on his face, and the teacher told me that she had not seen him smile all semester. Until I was bragging on him about doing this one. You got this one? This one worked. This one does not. Because the answers were, what, 1/2? And what, -4/3? That's true, guys? Were those actual answers? He's not gonna get those numbers over here with his little method. Now, why did he luck out in the one she was doing, all those that she was from that particular lesson, his little method worked. He listed all these and then started just plugging in and found which ones worked. It worked. These 2 worked. All of a sudden, this one, which she had not discussed yet with them, it will not work. What's the difference? Andrew, go for it.
The original one didn't have a leading coefficient, well, that one is the 6.
In fact, the leading coefficient on the first one that did work was what? A 1. Over here, it's not a 1. Of course, the kid at that age, he didn't recognize that. He just thought his little method would work on all of them. Didn't work. Did not work. Now, I talked to him, I worked with him as I sat there, and then I said, well, we might do this. Here we go, it's gonna lead me back to our problem. I said, we might do this and modify what you're doing. What you're doing makes sense, but in this case, it needs to be modified. So Andrew told me those leading coefficients are different. Why not take your possibilities here, 1, -4, I'll list them like this, -1, +4, 2, -2. Those are the factors that he was accustomed to for that constant. But let's modify it now. Let's use what you're doing. But it didn't work out here because of that 6. Then place on the bottom here the factors of 6. Which are what? 1 and 6. -1, -6. 2 and 3. -2, -3. Lengthy process, even with this. So guys, I said, go ahead and do what you've been doing. He did up here, but now modify it. You've got to list underneath the factors of 6. The reason it did make a difference here was because if I list the factors of 1, it's just 1 and -1. You don't see the effect over here. And then he said, what am I going to do now? I said, well, you're going to still test. You're going to plug in and see what works. He said, what number should I plug in? You got to be patient. Now I have like a quotient, a ratio, a fraction. 1/1, test it. 1/-6, 1/6, test it. Look how tedious this is. 1/-1, test it. 1/-6, test it. 1/2, test it. It'll work. Is 1/2 when I start comparing the top to the bottom? Is 1/2 when I finally get to it? Is that a possibility when I place that over that? And if he's patient and he goes back and plugs in 1/2 here, does the arithmetic, he should get a 0. Is that true? Who on earth has the time? And now say another answer came out. We know the other answer besides 1/2 was -4/3. Is that in there somewhere? Well, of course it is. You put this over this. But look at all the other choices you have that you go through until you might reach those 2. Oh my Lord. You follow what we were doing? At least he had another method. It would take forever though. Now, with that little story, let's go back here. Here's her problem. I'm going to sort of use what I used with him. So got it on top here. And we're going to name all this. We're going to list all the factors of my constant term. if you wish, you could write in a form like this, plus and minus 1, plus and minus 6. Okay here, plus and minus 3, let's combine them, plus minus 2. Then over all the factors of my leading coefficient, like the middle school kid had to do. For the 6, he had to list all the factors of 6 on the bottom there. But mine in this case would be, not too many fingers, for 2, plus and minus 1, plus and minus 2. Guys, notice you're taking the quiz next week. And I've got all my students, and all of a sudden you say, Professor, how on earth I'll be here all 60 minutes or 30 minutes or 45 minutes for that quiz? Suppose I go straight across, Professor, and I'm patient, and I tried 1 over 6, didn't work. I tried 1 over negative 1, didn't work. I tried 1 over negative 6, didn't work. And I look at the clock, and I'm running out of time. I haven't found one to work yet. Then all of a sudden, you see a classmate walk out. You see, how did you do so fast? They probably lucked out right now, and they probably said, well, I'm gonna try 1 over 2 first. It worked out, and they smiled. And the other answer came out being negative 4/3. Who on earth would think, well, we'll try negative 4 over 3. It works. They turn their paper in, they walk out, the other classmates look with a frown on their face like, well, they're smart. They're smart. I'm still testing. When 4 o'clock comes, I'm saying, God, I gotta go home. 4 o'clock? My class is still with me. They're still testing. So there must be something here that's going to help us cut down on some of those choices. The kid in middle school had no idea how to cut down the choices. We want to come up with some ways to cut down a lot of these choices and finding the ones that work. Guys, right now though, it looks like this. Your textbook labels this as, they use P over Q for the initials. P is the top part, those are the factors of your constant term, and Q, the factors of your leading coefficient, just like the kid in middle school. Now help me out. I've given you so many handouts. Could someone please look at the handout and see if we have one that has 3.3, 3.1, probably 3.3 on it. Please check. Is there a 3.3 or 3.4 somewhere in there?
I think it goes up to 3.2.
3.2 was the last one I gave you guys?
I think so.
Okay, and what did 3.2 have? What was it asking?
Graphing polynomial function.
Oh, graphing the polynomial functions. That's the last one you guys will receive from me. So I'm moving into 3.3 then. You don't have the handout yet. Oh. Okay, let me just talk about it a little bit here, then I'll try to find the handout for you. I thought I'd pass all that out to you guys. Guys, you follow this? You're going to do this, and they give a name for all this, and that's why I asked you if you had the handout yet. They give a name of what we're doing here. By the way, are all these possibilities that would be testing, are they classified as, I'll use the word, rational numbers? In other words, are they ratios? Are they fractions? And look at the possibilities here. 1 over 6, 1 over negative 1, 4 over 2, 2 over 3. Are they all like a ratio? Okay, so they call this, we're going to start using something called rational zeros theorem. That'll be on that handout when you get it. Throw this in. Rational zeros theorem. There's the word. That's why they identify this as your book chose P over Q. They could have chosen A over B for the ratio. Now, sure enough, we're going to finish this one up. We got tests. Now, I always ask this. Does anyone have, I'm not going to list all the possibilities like the kid in middle school gave. Does anyone have maybe one you think might work when you compare the top to the bottom and get a ratio? If so, I'll test it. Which one just sort of maybe calls out and says, please test me, I think I'm okay, I think it'll work? Does one have one? as a student, I don't think I could do it, but does anyone have maybe a favorite one? Yes?
Just one.
Oh, one, just one itself, 1/1. So 1/1 is a possibility. Right, does everyone see 1/1? We get a 1. Now, you say, Professor, that means I gotta go back and put a 1 in here? I'm gonna try it directly, like the kid in middle school. If I put a 1 in, I get 2 plus 11. What's that, 13? And then down here, if I put a 1 in, that's a -7. -7 subtract 6, is that a -13? What did they drop out? Did they give you a 0? Congratulations. So of those 3 zeros I'm expecting, he has given me, Professor, 1 works. I'm playing with you right now. Wait till you see what we're gonna do here. We'll make it much easier shortly. Does anyone have another possibility? There's 2 more zeros out there. And the sad thing is, if they have eyes in them, they're complex, you'll never find them in that set. They could be complex, let's hope they're not. Let's hope the other 2, we're hoping the other 2 are real rational zeros that were in that set here. Guys, does anyone have another one to try besides 1/1? Oh, I love this. I love this, I'm having fun. Give me another possibility. We've got 2 zeros in this. One, just at random, it may not work. 1/1, we lucked out there with his help. It could be 1/2, could be 6/1, could be 6/2, 3/1, 3/2, Professor. 2/1, 2/2. We have others to test. Does anyone have maybe a favorite? Yeah.
My favorite's -3/2.
-3/2. Okay, here goes. Now, if I take -3/2, like the middle school kid did, you have to plug it in right here, and I see right now you got a cube it. So a -3/2, I think, is a -27/8. Isn't that true, guys? Getting a little awkward. And then I put her -3/2, she gets -3/2 here, that's what, 9/4, times 11 gives her 99/4, oh, we're having fun. Look at the fractions. Okay, now, we, in a pre-calc class, we're gonna test. But we're going to test not by directly substitution. You see, right now, those fractions are crazy up here. Give me some nonsense. We can do fractions, but fractions sometimes will mess you up. We're going to do the checking, the testing. We're going to use something called not regular substitution. We're going to use something called synthetic substitution, or sometimes they call it division. Synthetic division. You said, Professor, what on earth is synthetic division? I've got to know how to divide myself. Long division. I'm ready to get through long division, Professor. Now you asked me to do something called synthetic. What's synthetic? Yeah, mathematicians came up with this. It's a quick way. Doing division is a quicker way. Gia, I'm going back to your, you said, remind me now, you said your -3/2. Here's the way it looks without going directly into it. We're going to block off her number on the side here. She wants me to test -3/2. Watch what's going to happen. Then we're going to go back and pick up all the coefficients, just the numbers, and my constant, and place those like this. I see a 2, they were like this, 11, I see a -7, and a -6. And we're going to do something. So take your number that you want to test, so you get me -3/2, then look back at your function, jot down the coefficients and the constant, all the numbers there. And here's the way it works. A little bit faster than directly doing it. You always start placing a 0 underneath the first number. And you add them up in that column. 2 plus 0 gives me a 2 here. Then, it's just a quick little process. Now you multiply these 2 together. If you multiply these 2 together, I think the 2's drop out. Do they? -3/2 times 2, will the 2's cancel on the side there? That gives me a -3. That goes there. Then you add those 2 up. 11 subtract 3, that's 8. Watch carefully. you take this, her number, times 8. And I know 2 goes in 8 4 times 3 is what, 12? Negative 12. Guys, see if I did it correctly. Did I do it correctly? 2 goes in 8 4, then 4 times 3 is 12, negative 12. Now, if I copied the thing down correctly, this now, Gia, is negative 19. Is that true? Now, are we gonna get awkward here? Because I think if you take 3 halves times 19, I can't cancel 2 into 19, too bad it's not a 20. It's awkward. So I see right now, there's no way am I gonna finally get something here and add them up and hopefully the end will be 0, which means it worked. So as soon as you see that awkwardness coming in, it's not gonna work, forget it. So, Gia, negative 3 halves is not one of the answers. Now, PK, negative 6. Hang on. And that's one of your favorite numbers. Here we go. 0, 2. Always start like that. Product, that's a negative 12. That goes here. Add them up, that's a negative 1. Product now, positive 6. That goes here. Add them up, that's a negative 1. Product is what? Positive 6. Ah. She found one that works. She found negative 6. By the way, guys, negative 6, we're in my back here somewhere. Negative 6, yeah, right here it is. That would be a possibility. Negative 6 equals 1. It worked. Now, if you find 1 to work, here's one possibility. You could say, Professor, after I find 1 to work, gives you a 0 on the end. May I continue and test others underneath here with the remaining numbers and try another number? And I'll test it, and let's see if it works. You get to stack them up after you find 1 to work. Yes? Are you talking about 1 or negative 1?
1.
You want 1, positive 1. Let's try 1. Okay, 0 here, 2. 1 times 2 gives me a 2. Add them up, you get a 1. 1 times 1, 1. Congratulations. Step back and look at this. Congratulations. Did her 1 work? Nice. How many zeros am I expecting? 3. We have 2 of them. Now, here goes. Does anyone think they have a possibility for the last 0? I'll test it, and I'll stack this up, and we're looking at just those 2 now. What do you want to try? Negative 1? Let's try negative 1. Here goes. 0. 2. Product, negative 2. Whoa, whoa, whoa. Is that negative 2? Not gonna work. Anyone else? We need 1 more. 0. Let's see if we got it. Yes.
Negative 1 by 2.
Negative 1.
1 over 2.
1 half?
1 half.
Oh, by the way, guys, negative 1 half, a negative 1 over, yeah, that's a possibility. It wants to be tested. Here goes. 0, always here first, add them up, 2. Product, 1 half times 2, 2 is cancer, you know that's a 1. In fact, it's a negative 1 in this case. And look at that, you get your 0. Wow, wow, wow. Do we now have 3 zeros through the synthetic substitution? I'm gonna listen right here next to my, oh, we got 1 already listed here. With the help of student, we've got negative 6, works, Professor, and negative 1 half works. And those are my three zeros. For this polynomial function. If I were a student seated, I'd say, Professor, you give me one of these, and I know you, Professor, by now, you're gonna give me a hard one. You're gonna probably have this, maybe up to a 6. We're gonna have to find 6 zeros. I did 3 here. Look how much time it took for 3. If I say find 6, find 8, you'll be here for the hour, doing one problem. But it works. It's called synthetic substitution. I love synthetic substitution, but I don't like all that testing. Sometimes you'll get aggravated with yourself. Sad thing is, I've had students, some of my best students, they'll get a little excited about the test or whatever, and they'll test one here, and one did work, and they make a mistake in the arithmetic here, mess up, they think it didn't work, and they leave it. Then they go outside and cry. Yeah, I see them open the door, they come back in and say, Professor, what's the answer to that one? 1. I tested 1. You did? Yeah. But rather than a 2 here, they put a -2. All kinds of ways to really slow you down. So we've got to be very careful on one like this. Yes?
For synthetic substitution, if we were to do it with, say, like, if it showed like 2x cubed minus 7x, would we input like a 0 for the x squared?
Well, no, you mean if there's a term missing,
Yeah.
Yeah, if there's, you got to put something called a placeholder in. So if I got an x cubed, I gotta have an x squared. If not, you gotta put a 0 in there as your placeholder. So that's what they're gone. This one has everything it needs though. Got a good point. Yes?
If you were to graph something like that, how would you know the multiplicity?
Hang on. Guys, you read this? Now, before I take Andrew's concern, see what's gonna happen. First, this was not in the form of this. This was the easiest one on the board. I gave it to you in factored form to begin with. This one was not given to you in factored form. Now, let's put it in factored form. Let's rewrite P of X, right here, in a form that looks something like this. Now, you say, Professor, what are you doing here? Well, I know the zeros. Can anyone tell me what factor might I write here to show that -6 should be a 0? -6 should be an answer. What should I list here as a factor to ensure that? There we go. X plus 6. We got 1 to come out. What factor might I write to ensure that 1 is a 0? X minus 1. And what you're going to have to be careful with is, that's the reason I brought this in, -1/2. And be cute here, -1/2. Here's something.
2x plus 1.
Let's say no fractions. Oh, I heard it, say it again.
2x plus 1.
2x plus 1. You solve that, you get -1/2. Now, there's the black function, right there, factored. And now it looks like what I started out with on this one to begin with. Now it's factored. Please tell me, would it have been easier for me to have given you to begin with, and we could have taken a break earlier, would it have been easier for me to have given you this and say, what are the zeros? The blue. Once I gave the blue to you, I said, what are the zeros? You say, Professor, are you kidding? It's -6, +1, -1/2. I didn't give it like that. I gave it like this. So you had to go through synthetic combining and then write in factored form. Andrew, I haven't forgotten you. The degree here is 3. Right? The degree here was 3. I takes 1. If I multiply all this out, all these out, and add the exponents, am I going to go right back to that x cubed? Right now at this point. So do I need to place anything on the outside, like sometimes we'll see a 2 placed on the outside, or a 4 placed on the outside? I don't need that here. I've cleared everything. I've taken care of everything. know we've got about 5 minutes. I've got to show you something else, which I think you're gonna appreciate. I'm just finishing the problem up. The problem's finished. By the way, could we graph this now? That's where the test is gonna load next week. After you write this thing out, then I'll say, now, graph this. You'll say, Professor, well, you just graph some. You go to the, grid, you place your zeros, your x-intercepts. You see if it's gonna cross or touch. Looks like, in this case, it's gonna cross on all of them. You look at the end behavior, you get a graph of this, which represents the graph of this. Is that true, guys? I can actually graph this now, in no time. But, without graphing it before the break, let me show you a little shortcut if you're on the alert as you do this. We were expecting 3 zeros. That's a cubic. As soon as we find one to work, I think I tested -6 first, and it worked, didn't it? We looked out -6. Guess what that does? That drops the degree down by 1 because we already found one to work. This now goes down to a quadratic. As soon as I find one to work, we found was it -6? Yeah, -6 worked. That now takes me down to a quadratic. Oh, I love this. Guess what the quadratic looks like at this point. So I'm gonna name the quadratic with the remaining numbers after I tested and found one to work. As soon as you find one to work, it drops down 1. So I should now be into a quadratic. Can anyone tell me what these numbers might name that quadratic as?
2x squared minus x.
Whoa, 2x squared
Minus
minus 1x
minus 1.
minus 1. Are you kidding? Therefore, without doing this right here again, without additional testing, if I had noticed that, I can now factor this, not test. I got a link to a factor into 2x and x, and probably -1 plus 1. Let me check my math out. It does. Split this up. This one, when you solve it, gives you a -1/2. Which we got earlier. This factor will give you what? 1, which we got earlier. And therefore that would save you from additional testing. Oh, we're gonna have fun. Is there a quiz tonight? All right, I should cancel the quiz and just do this the rest of the time. Isn't that cute? That is cute. Let's see. Yeah, I'm gonna stop for a break. I am going to, after you get back from the break, I am going to graph this. I'm going to graph this, where is it? This function. Those zeros and all this. Guys, look at that. Before we leave, I don't think in middle school, I wasn't thinking like this. Who on earth would think, as that kid was thinking, I don't know where that kid is these days, to list those factors in chess, and he was doing it.